We're going to blame Adam right now, but unfortunately, it's still a little bit cold outside.
But how and why exactly do we feel cold? Our wise gal, Nadia Mason, physics professor from the U of I, joins us today. Nadia, what are we doing here? We've got a lot of things on the table.
Right. Yeah. Okay, great. So today we're talking about the difference between actual temperature and feels like temperature. So if you notice when you look at the weather in the morning, there's two temperatures listed, and it might say actual temperature is 20 degrees, but feels like -5. And that's a huge difference, right? So the question is, why do we have those differences and why do we feel cold? Okay. So these are things that, and next week we're going to talk about how to keep warm and prevent ourselves from feeling cold, which is what I like to do. So the first thing to note is our bodies are really warm. Our bodies are 98.6 degrees Fahrenheit, as we know. And that's because we have internal engines, which are our cells, which are continuously burning food to keep us warm. So our cells are burning food, and we're just producing heat all the time. But the problem is that heat flows from hot to cold. And so the heat is always trying to leave our bodies, right? And sometimes our internal engines can't keep up enough to keep us warm against this flow of heat going out all the time. Okay. Right. Okay, good. Yeah.
That's why.
Exactly. So the heat's always flowing. And actually, what I have something here. What I have here is a heat-sensitive film and just a hair dryer, very technical. And I'm going to just show the heat flow on this. Okay. So if I turn on this dryer, you can see the heat. Can you see? Take that down. Can you see the heat flowing down this thing?
Oh yeah.
See that? So that you can see the heat.
Yeah.
You can see the heat moving out on that, right? So you can see the heat flowing. And actually, if I take an ice cube, we got a little bit.
This is where Anthony gets involved.
Anthony gets involved. So Anthony's going to put ice on the heat and show that it prevents this flow. Oops. Let's do that. Turn on the hairdryer. So just put it up a little closer. So you can move it up. Keep moving it. See that?
Well, we get the gist, right?
We get the gist. So basically, that's what cold air does to our bodies, right? Our bodies are producing heat, but that cold comes in, and our bodies just can't produce enough to keep the heat from flowing out, just like that ice cube prevented any effect from happening on here.
That was cool.
So,
So this is also the excuse for the smart kid who wants to be like, hey, Mom, I can't let the cold air in because actually cold air goes, or warm air stays in and goes out all the time.
That's right. So that's great. There's two effects here, and that's the second one I want to talk about. So the first is just what we call conduction, right? You touch something cold, the cold air touches our bodies, it takes the heat away, and we feel cold. The second effect is that we have radiated heat. So our bodies are also just producing heat all the time, and we call this our body heat, right? That's why we huddle together when it's cold, if you're stuck in the woods or something. you want to use that body heat to some effect. And so we're always radiating heat. And so, we're just little living radiators. And so here's another example of just a radiator, and you can see, if this gets hot enough, you can see that even at some distance, we should get some effect on this film. You can see that changing at some distance, right? That's just, it's radiating heat out. You see that color change on this film. And that's what our bodies do all the time. Now, if you have a wind, then what the wind does is it comes and it blows the cold air and it replaces that radiated heat around our bodies, right? So usually we have a little bit of radiated heat that hangs around our bodies and keeps us warm. But when the wind blows, the cold air rushes in, replaces that warm air around our bodies, and makes us feel colder. Okay, so that's what the wind chill does. Usually we have a little bit of warm air, but the wind chill comes in. So the faster the wind is blowing, the more that cold air replaces the hot air. So the second effect is exactly that cold air is heavier and it replaces the hot air that rises up. Okay, so and that's what we have in the weather. That's exactly right. That's the convection process, and that's why we feel colder, because our body loses that body heat. And actually, you can see that in this demo over here. What we have here is a radiator over this side, and so it's making this air hot. Okay, so this air over here is hot, and this air over here is cold. And you can't see it, but the cold air is rushing in and replacing all the hot air right now. Okay, so you're wondering, that's not cool because I can't see anything. So I have some matches. I'm just going to make some smoke, and the smoke you'll see will rush down, and you can actually see that air being replaced. So playing with fire, which is also fun. Okay.
Don't worry, the fire extinguisher.
Just to make smoke. So watch inside the tube.
Oh.
So you see, that's just air. that's just the cold air replacing the hot air. So that's like our bodies. And this is the cold wind rushing in and taking away our body heat and making us colder. So the two things, conduction, having the cold air touch our bodies and take heat away, and this is convection, which is the wind blows the cold air away to the hot air away, replacing it with cold air.
For the
and making us
record,
colder.
I just started clapping, and I don't know why. I don't know why, but I started clapping. Yeah.
You know, science is amazing. That's why.
That was
You know
cool.
what? It's when you see it go so fast on the other side, you're like, whoa, it's really fleeing. There's something about the way it moves that I can do that again, but we'll do it after. I love
That
the
is
fire
awesome.
song. We'll do another
Yeah.
fire segment.
Yeah, let's some fire here.
And we're continuing to discuss this discussion next week.
Yes, so we're going to talk about materials that can keep us warm. They prevent the cold air from being replaced, so they can prevent the conduction process. So
Long Johns.
yes, layers. Yeah, my daughter wants me to try marshmallows as insulation, so I'll see if that works too.
You bring marshmallows.
Love, right? I think air, air, long johns, marshmallows. We'll try it all.
All right, thanks, Nadia, so much.
We'll be right back.